Hello everyone. So today we are going to implement unsupervised machine learning algorithm, and we are going to use the most renowned dataset, that is iris dataset. As a iris is a well-known flower species, it's having so many species under the iris, and today we are going to clustering all these species. It means we are going to grouping them into the same characteristics, and for this we are going to use an unsupervised machine learning algorithm, k-means. Okay, so what's our objective of this task is, from the given iris dataset we have to predict the optimum number of clusters and represent it visually. We have to analyze how many clusters are needed, and we can say how many optimum number of clusters are there for analyzing this data set. Okay, so first of all we are going to import the necessary libraries. We have imported numpy, pandas, matplotlib and seaborn. Now we are reading the data set as it's in the CSV format, so we are using read CSV. Now the time comes to explore our data set. So here we'll see how our data look like. We can see, like, in our data set we have 150 rows and 6 columns. Okay, so 6 columns includes ID, sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter, and the species. Okay, so we have a 3 species in iris dataset of the flowers. This is versicolor, virginica, and setosa. So we have to cluster them according to their characteristic. Now we are going to check the data types in our data set. From here we can see we have only the species column which is in the object format, and other columns are in the numerical format, that are integer and the float. Now we are going to create different data frames for numerical and the categorical values. Since we both have numerical values and the categorical values, so we have to create different data frames to apply scaling on this data set. So we have created this two data set, num char, and now we are exploring this num data set. Now we are seeing that it contains only the numerical values. These all sepal and petal length and width in centimeter. Now if we'll use a describe function for the num data set, we can see, like, we'll explore data set little bit. We'll be able to see for the sepal length its minimum value is 4.3 and it will go towards the maximum, it's 7.9. And same like this we can analyze for other columns also, like for sepal width, petal length, and the petal width centimeter. So this is a simple diagram to show like what is petal and sepal, and how we are going to analyze the width and the length, like which part is the length and which part is the width. Now, as we have seen that in our data set we have a categorical feature also, that is species. It's in the object format, so we need to do the character encoding. Okay, so here we are doing the encoding, and from this we can see we have created 3 new columns after doing the encoding, and 3 columns have 3 different values. This is for the species iris setosa, this is for versicolor, this is virginica. So now we are going to concatenate these two num and character dataset into the XOR. Now we are going to do the feature scaling, so that we'll have all the values like the mean, approx 0, and the standard deviation up to the 1, so that it would be easy to apply the algorithm and our result would be more efficient. So after applying the standard scalar, here it will use the describe function on the x data frame. We'll be able to see all these mean, standard deviation, minimum value, maximum value, and all others. And now we are going to apply the k-means clustering algorithm on our data set. Okay, so in the k-means clustering we are going to plot WCSS plot, and we'll use elbow curve to find the optimum number of clusters. This is a sum of a square for distance. And now we are going to find the appropriate cluster numbers. For this we have used this sklearn.cluster import k-means. We are using the k-means to analyze this, and we'll plot this graph, we'll be able to see like this. The elbow method is the graph between the number of clusters and WCSS, and on the basis of this we can identify the number of optimum number of the clusters, and from this diagram we can choose 3 as the optimum number of cluster for the sake. And now, while keeping 3 as a number of clusters, we are going to check how our data looks like and how our clusters are grouping on the basis of different characteristics among different clusters. So here we are checking how many values we have in different clusters. So if we'll check like this, we have 50 values in all three different clusters, 0, 1 and 2. And now we just want to see the mean values of all these columns and the with the clusters labels, and we can analyze all this. Like in the cluster label 0, the sepal length mean is 5.006, its width is 3.418, its petal length 1.464, and its petal width means 0.244. Same like this we can see for the cluster label 1 and cluster label 2. So what we can infer from this, like we had the whole data set of 150 rows, and now it got converted into the 3 cluster having 50 rows in each cluster, and whatever rows it contains in each cluster, it's showing the mean of all those columns like sepal length, width, petal length and width. So for the visual representation, we just want to plot clusters with swarm plot. So here we are using the swarm plot to plot the graph between the cluster label and the species. So with the help of this visual graph, we can see like in the 0 cluster label, we have iris setosa at the maximum value, and in the cluster label 1, we have this iris versicolor, and in the cluster label 2, we have this iris virginica. So from this we can conclude like we have clustered all these species into the 3 groups on the basis of their characteristics. So if we'll summarize this, we can say like for the iris setosa, which is falling under the cluster label 0, have sepal length centimeter mean is 5.006, and similarly for all those values, these all 4 values, sepal length, width, petal length, width and sepal length, all these are for the iris setosa, which are falling under the cluster 0. And for iris, same for the iris versicolor and iris virginica. So on the basis of these characteristics, we can divide all these species or 3 species into the different clusters. So this is our final conclusion of this task, like how we have made the clusters from the given data set and how we are able to identify the patterns in the given data. Thank you.